Hello my dear students. In the previous session we had discussed about the image formation by spherical mirrors. And in the today's session we are going to discuss some more important concepts regarding the reflection by spherical mirrors. Yes? First let us consider what are the uses of convex mirror and concave mirror here. So far we have learned how the images are formed by spherical mirrors, that is concave and convex mirror. Here we are going to understand where do we use these concave and convex mirrors. First let's see the uses of convex mirrors here. Convex mirrors are used in vehicles as rear view mirrors to see traffic behind us. We have studied that the images formed by convex mirror have the nature, that is it forms erect and diminished image. Yes? And while driving the vehicles, we know that two mirrors are fixed on both sides of the vehicle. What is the need of fixing only the convex mirror there? Because it forms erect image. And also in order to see the wider field of view, we need the convex mirrors there. While driving, we require to see the traffic behind us, which covers the wider field of view. As it is curved outwards, it can cover the larger area behind us, because of which we will use the convex mirrors. Yes, convex mirrors are preferred because they always give an erect images. Yes, we know that it will form an erect image, and also as it gives the wider field of view, we will be seeing the large area of the traffic behind us. Even though it is diminished, we are able to see the wider field of view of the traffic behind us. So it will be safety for driving. Yes. Now let's see the uses of concave mirrors here. Concave mirrors are commonly used in torches, searchlights and vehicles headlights to get powerful beam of light. We know that concave mirrors are converging mirrors. Yes. In order to get the powerful beam of light, we need to focus the light in a specific way. Yes, the light rays should not get diverged. So, converging mirrors are very helpful in this situation. And it is also used in shaving mirror to see larger image of the face. We know that concave mirrors form enlarged images. They can form enlarged images. So while shaving, in order to see the larger image of the face, and in case of dental hospitals, the dentist will also use the concave mirrors in order to see the enlarged image of teeth. While detecting any cavity or any problem in the teeth, we are going to see the enlarged image of the teeth. For such cases, we are going to use concave mirrors as it forms the enlarged images. Yes? And large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. In solar furnaces, the sunlight is trapped for production of heat. Yes, concave mirrors have the capacity to converge the light. They have the property of converging the light rays. So, in order to concentrate large number of rays at a specific point, we are going to use this kind of concave mirrors, so that large amount of light rays are trapped on those solar furnace. This is about the uses of concave mirror. Now we are going to study the most important part, that is sign convention for reflection by spherical mirrors. What is sign convention? It is applying positive or negative symbols to some measurements. That is called as sign convention. Now here what is the necessary of using sign convention in case of reflection by these mirrors? Because while dealing with the measurements, in order to get more clarity of the concept, we will use the sign convention. For example, if I say focal length of a mirror is 2 centimeter, then here we will not understand whether we are talking about concave mirror or convex mirror. If we apply particular signs for particular measurements, then it will be easier to understand what type of distance we are talking about, what type of mirrors we are talking about, and also considering the various measurements like height, object distance, image distance, we will be getting clarity regarding those measurements if you apply the sign convention there. Yes, let's see. First point is the principal axis of the mirror is taken as x-axis of the coordinate system. See here, this is the principal axis of the spherical mirror. Yes, that too concave mirror here. We are considering this principal axis as the x-axis. This is x-axis. And we are considering pole P as the origin. Okay, and whenever we are considering any distances, we are considering it from the pole. Suppose we are talking of the image distance or object distance. All these distances are measured from this pole. Yes. Next, object is always placed to the left of the mirror. For our convenience, what we do is always the object is placed at left side of the pole or left side of the mirror. And all the distances measured to the right of the origin are taken as positive. This is right of the origin. Yes, all the distances which are measured to the right of the origin, they are taken as positive. And those distances which are measured to the left of the origin. Origin means here pole. When we consider the right of the pole, the distances are given positive sign. When we are talking of the left side of the origin, the distance are given negative values. Yes, and also the distances measured perpendicular to and above the principal axis are taken as positive. This is the x-axis. Whatever the distance measured perpendicular to and above the principal axis, they are taken as positive. And when you are going to measure the distances below this x-axis perpendicular to the principal axis, it is taken as negative. Suppose what happens, sometimes the image is formed here. We can take the height of the image as positive as it is formed above the x-axis. Sometimes the image may form below the x-axis. At that time, we have to consider that as negative because the distance measured perpendicular to and below the principal axis are taken as negative. It is about the height. And now suppose if you are considering the object distance here. Always we said that object is placed at the left of the mirror to the left of the pole. Means we know that distance towards the left is always taken as negative. So object distance is always taken as negative. But what about image distance? It depends on the type of the mirror and type of the situation. If we are getting the image on right side of the mirror, then we are going to get the object distance as image distance as positive. Suppose if we are getting the image here, it is to the left of the origin. So now we are considering the image distance to be negative. In such case, image distance will be negative. It depends where the image is formed. If the image is formed on right side of the origin, then it is taken as positive. If it is formed on left side of the pole, then it is taken as negative. Yes, suppose consider here, this is convex mirror. We know that principal focus of the convex mirror is behind the mirror. If we want to take the focal length, this is the focal length. The distance between pole and the principal focus is called as focal length. Yes. Now this focal length distance is measured towards the right. Yes, it is measuring towards the right of this pole, because of which the focal length will be positive. If we are considering the focal length to be positive, then it indicates that we are using convex mirror. In case of concave mirror like this, what happens? The principal focus will be towards the left of the origin. It will be towards the left of the origin. In such case, always the focal length will be negative as we are measuring the distance towards the left of the origin. Understand how these signs are given. Please do not get confused with these signs. It is very easier to understand if you focus on this concept. Yes, do not rote memorize anything in this concept. Now, when we are talking about the height, if the erect image is formed, suppose if the erect means upright image is formed, then the height will be positive if upright image is formed, because we are measuring the distance above the axis, above the principal axis. If the inverted image is formed. If the inverted image is formed, then the height will be negative. See here, this is the invert image. We are measuring this distance below the axis. In such case, the height will be negative for inverted images. In this way, you have to apply the sign convention for the distances like image distance, object distance, focal length, height of the image, height of the object. In this way, height of the object will be taken as positive because it will be always on the principal axis for object distance, for object height. Whereas image may be positive or negative. The height of the image may be positive or negative. It depends what kind of image is formed, whether it is erect or whether it is inverted. Yes, this is about the sign convention for reflection by spherical mirrors. If you understand this sign convention, you will be very easy. It will be very easy for you to solve the numericals. Yes. Now we are going to talk about mirror formula and magnification. Mirror formula, it is the formula which gives relation between focal length, image distance and object distance. Yes, it gives relation between image distance, object distance and focal length. And it is given by the formula 1 upon f is equal to 1 upon v plus 1 upon u. We know that f is the focal length, v is image distance, u is object distance. And here also we will be using the sign convention for the measurement of distances. Like for focal length in case of convex mirror. See here, this is convex mirror. This is the reflecting surface. We know that in case of convex mirror, the principal focus will be behind the mirror. It will be towards the right of the origin, that is right of the pole. So the focal length, which is the distance between pole and principal focus, it is to the right of the mirror, that is right of the pole, because of which we will take f as positive in case of convex mirror. Whereas in case of concave mirror, this is the concave mirror, this is the pole, this is the principal focus. Yes, the principal focus is towards the left of the pole. So the distance measured according to the sign convention is taken to be negative. So this focal length, which is distance between the principal focus and pole, is taken to be negative. So it is about the focal length. What about the object distance? We know that always the object is placed at left side of the mirror in both the concave and convex mirror. Here also we are placing the object towards the left side of the pole. So when the distance is measured towards the left side of the pole, we take it as negative. So always the object distance will be negative. And the image distance, it depends where the image is formed. If the image is formed behind the mirror, that is towards the right side of the pole, then it is taken as positive. If it is formed in front of the mirror, as in case of concave mirror, it can be taken as negative there. It depends where the image is formed. In case of focal length, it is taken as positive for convex and it is taken as negative for concave. Yes, this is about the mirror formula. Why it is used? If you are given the image distance, object distance, then it is easy to calculate the focal length. If you are given the focal length and the image distance, then you will be able to calculate the object distance. In this way, by knowing any two terms, the third term can be calculated easily by using mirror formula. Yes. Now, this is one more concept that we are going to study here, magnification. Magnification means it is the extent to which the image is enlarged or diminished with respect to the object. Yes, it is the extent to which the image is magnified with respect to the object. We know that in some cases the size of the image is less when compared to the object. In some cases the size of the image is same as that of the object. In some cases the size of the image is enlarged when compared to the object. So we are going to calculate here the extent to which the image is magnified with respect to the object here. And this magnification is given by the formula m is equal to height of the image by height of the object. H dash is height of image, h is height of object. And we know that always the object is placed above the principal axis. So the height of the object is always taken as positive. And height of the image, it depends whether the erect image is formed or the inverted image is formed. It depends on that fact. Yes, and this magnification is also related to the image and object distance. It is given by the formula negative of image distance, that is v, by object distance u. If the magnification value has negative, it indicates that the image formed is real. If it is has positive sign, then it indicates that the virtual image is formed. Let's see how the magnification value will give information about the nature of the image. For example, if I say the magnification of the image is 2, this indicates that the height of the image is 2 times that of the height of the object. What does this mean? That image is enlarged, image is magnified, as it is 2 times that of height of the object. When the image is 2 times that of the object, it indicates that the image is magnified. This is one information we are going to get. And also, if I get the case that magnification has the value of minus 0.6, if this is the value of magnification, this negative sign indicates that the image formed is real. Negative sign indicates image formed is real. And positive sign indicates that the image formed is virtual. And you can observe the value here. It is 0.6. Means the height of the image is 0.6 times that of height of the object. 0.6 indicates that the image is diminished. It has smaller size when compared to the height of the object. If it is more than 1, it indicates that the image is magnified. If it is less than 1, it indicates that the image is diminished. If it is equal to 1, it indicates that the image is having the same height as that of the object. Yes, this is the information that we are going to get from the value of m, because of which we have said that it gives the extent to which the image is magnified, whether it is diminished or it is enlarged in this way. Yes. Now let us solve some numericals here. Let me read the first question. An object is placed at a distance of 10 cm from a convex mirror of focal length 15 cm. Find the position and nature of the image. Here we have to find out the position and nature of the image formed. Yes, what are the given quantities here? They have given the object distance and focal length. Yes, object distance u is equal to minus 10 centimeter. We know that always the object is placed on the left side of the mirror. So we have taken here minus sign. And also they have given the focal length 15 centimeter. As it is convex mirror, we have taken here positive sign only. In case of convex mirror, the focal length has positive sign. Now we have to find out the image distance. We know the formula 1 upon f is equal to 1 upon u plus 1 upon v. We need to find out this v. 1 upon v is equal to 1 upon f minus 1 upon u. It is 1 upon 15 minus 1 upon minus 10. It comes out to be, so 1 upon v is equal to 1 upon 6, which means v is equal to 6 centimeter. You can observe here the image distance is in the positive sign, which means it is formed behind the mirror. What is the position of the image formed? It is formed behind the mirror. And also we know that in case of convex mirror, the image which is formed behind the mirror is virtual and erect. So let us write the nature of this image formed. Position, it is formed behind the mirror. And what is the nature of the image formed? It is virtual and erect. Now let's see one more question here. The image formed by a spherical mirror is real, inverted, and its magnification is -2. If the image is at a distance of 30 cm from the mirror, list two characteristics of the image formed if the object is moved 10 cm towards the mirror. We have to find out the characteristics of the image formed. For that, we should know actually where the object is. They have given, we have to find out the characteristics when the object is moved 10 cm towards the mirror. Actually, we don't know the exact position of the object now. So, first we need to find the position of the object for this. Yes. What are the given quantities? They have given magnification is equal to -2. And also they have mentioned the image distance here. V is equal to -30 centimeter. Why we have taken minus here? Because this image is real, which means it is formed on the left side of the mirror. Now we have to find out the object distance. We know that m is equal to minus v upon u. So u will be minus v by m. It will be minus. So it comes out to be minus 15 centimeter. So the object was first at 15 centimeter from the mirror. Now if we are moving the object 10 centimeter towards the mirror, then where will be the position? Let's see. First, for that we have to calculate the focal length, which is given by 1 upon f is equal to 1 upon u plus 1 upon v. It is equal to 1 upon minus 15 plus 1 upon minus 30. It will be 1 upon, it will be 30 minus 1 by 10. The focal length is minus 1 by 10. No, 1 by f is minus 1 by 10. F will be minus 10 centimeter. Now what is the case here? It is the concave mirror. This is the pole. This is the focus. Initially the object was placed at a distance of 15 centimeter. What we have calculated here. Now we are moving this object towards the pole by 10 centimeter. So now the object distance will be 15 minus 10, that is 5 centimeter. It will be minus 5 centimeter, as we will take the negative sign for the object distance as it is placed at the left of the pole. So now see here, the focal length is 10 centimeter. Now if the object is moved towards the mirror by 10 centimeter, it will be at 5 centimeter from the mirror, which we have got here. So it will be at 5 centimeter. It will be now placed at here. Means you can see here, this object is between F and P. Means now if the object is moved 10 centimeter towards the mirror, then it will be between F and P, that is focus and pole. So what will be the nature of the image formed in case of concave mirror then? It will be virtual and erect. Yes, the nature of the image is virtual and erect. And what is the size of the image? It will be enlarged. We know that when the object is placed between focus and pole, in case of concave mirror, then the nature of the image will be, it will be virtual and erect and it will be enlarged. This is the characteristic of the image formed in this case. Yes. Now we are going to understand one more concept of light, that is refraction of light. This is a very different phenomenon when compared to reflection. In case of reflection, we were considering the phenomenon where light was traveling in a single medium. It was not getting transferred from one medium to another medium. We were considering a reflecting surface here. Whenever a light is incident on this surface, this ray of light get reflected back. It was not passing from one medium to another medium in case of reflection. Here, in case of refraction of light, we are considering the traveling of light from one transparent medium to another transparent medium. What happens when the light is moving from one transparent medium to another transparent medium? We will understand these concepts. Yes, let me give you some examples here. Whenever you take a container containing water and you place a pencil in that container. A pencil which is perfectly straight, once you look this pencil keeping it in a bowl of water, how does it look? It looks bent. The pencil is bent, even though it is not bent actually, but it appears like it has bent. And also you might have seen that whenever you place a coin, in a tank of water, what happens there? If you look that coin from outside, it seems like as if it is raised above from the surface. And also you might have observed that whenever a glass slab is kept over a printed material, the letters seems to be raised above. Why does this happen? What is the reason behind it? This is all due to the refraction of light. What happens here is, here whenever the ray of light falls on this pencil, here, then move here, they are entering into the different medium. The rays of light are entering from one medium to another medium. This is medium of air and this is medium of water. Because of which there is a change in media, the light will show the phenomenon of refraction. So what is this refraction then? It is a phenomenon of bending of light. Whenever the light travels from one medium to another medium, it happens only when it transfers, it will move from one transparent medium to another transparent medium. Yes, it is the phenomenon of light, phenomenon of bending of light when it travels from one medium to another. This is called as refraction of light. Because of this refraction of light, these things are observed here. The pencil which is kept in the water medium, half of the pencil is in the water medium, half of the pencil is in the air medium. Yes, when we look it from the outside, what happens? The pencil seems to be bent because of refraction of light. When the rays of light enters from air to water, these rays are bent, and when these rays are bent, these bent rays get reflected back to our eyes, because of which this pencil seems to be bent here. Similarly, in the case of coin also. And when you replace this water by another liquid here, if you take oil, then also there is a bending of the pencil. Bending of the pencil is seen, but the extent of bending is different from that of water. As you go on changing the medium, the extent of bending is different for different substances. It is not same for all the substances. If you take oil, then the bending of the pencil is different. If you take water, then the bending of the light is different. And when you consider this refraction for the glass slab, which is kept on the printed material, there also we see when we replace that glass slab by the plastic transparent slab, the extent to which the letters are raised above is different. This shows that the bending of light is different in different medium. Why does this happens? Let us see. Yes, this is the interface separating the two medium. Suppose this is medium 1 and this is medium 2. This is the normal perpendicular to the interface. Interface means this is the boundary separating medium 1 and medium 2. Whenever a light is incident on the interface separating the two media, it gets bends. It will be bending. And remember, the bending may be away from the normal or towards the normal. It depends on the medium. Okay. This is the incident ray. This is refracted ray. The ray which falls on the interface is called as incident ray. The ray which gets refracted is called as refracted ray. And this incident ray makes an angle theta with this normal, and the refracted ray also makes some angle theta dash with the normal here. This theta is called as angle of incidence and this theta 1 is called as angle of refraction. Both of these angles are different. Yes. Now we are going to understand about the laws of refraction. The incident ray, the refracted ray and the normal to the interface of the two transparent media at the point of incidence all lie in the same plane. See here, this is the incident ray, this is the normal, that is perpendicular line to the interface at the point of incidence. This incident ray, this normal and this refracted ray, they all will lie in the same plane. This is the first law of refraction. Then the next law of refraction states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of given color and for given pair of media. This states that sine of angle of incidence, sine of angle of refraction, the ratio of these two is constant. We had seen here, this is the angle of incidence and this is angle of refraction. When we take the ratio of sine of angle of incidence to the sine of angle of refraction, this comes out to be constant and it is constant for given pair of media. If I take the media pair, that is air and water, for this is constant. Sine of angle of incidence and sine of angle of refraction is constant for this pair of media. If I take oil and water, there also it is a constant. And also this ratio, that is sine of angle of incidence and sine of angle of refraction, this is constant for given pair of media and also for the light of given color, that is for a particular wavelength. This is constant. Yes. This is also called as Snell's law. This second law is also called as Snell's law. Here we have understood that this ratio is called as constant. There is a special name for this constant here, that is called as refractive index. What do we mean by refractive index then? When a ray of light that travels obliquely from one transparent medium to another transparent medium, it will change its direction. The extent of the change in the direction that takes place in a given pair of media is expressed in terms of refractive index. What is this refractive index? It is the extent to which the rays are bent when they are traveling from one medium to another medium. It is given by the constant, that is it is denoted by n, which is equal to sine of angle of incidence to the sine of angle of refraction. This constant is called as refractive index. N is refractive index. And this refractive index is also related to the relative speed of propagation of light in different media. Till now we have understood that whenever a light ray travels from one medium to another medium, there is change in the direction. What is the reason behind it? Whenever there is a incident ray falling on the interface between two media, it will change its direction. Yes, this we have learned. Why does this happen? Because the speed of light is different in different media. This is one media and this is another media. Whenever this light travels from one media to another medium, one medium to another medium, there is change in the speed of that light, because of which it is bent. It is bent either towards the normal or away from the normal. Yes, speed of light is different in different media. This is the reason why the refraction takes place. So, because of which this refractive index is related to the speed of light, and it is related in this way: the refractive index of any medium, it is equal to speed of light in air, that is ratio of speed of light in air to the speed of light in that medium. It is c, means speed of light in air is given by c, and speed of light in that medium is v. This gives the refractive index of the medium. You can take any two medium and you can calculate the refractive index once you know the speed of light in those two mediums. For example, this is one medium, medium 2. This is medium 1. This is normal at the interface. Now, the ray of light is falling on the interface and it gets refracted. Yes? Now, the refractive index of the medium 2 with respect to 1 is given by refractive index of medium 2 with respect to 1 is given by speed of light in medium 1 to the speed of light in medium 2. And in the way you can express the refractive index of the medium 1 with respect to 2, that is given by refractive index of the medium 1 with respect to 2 is equal to speed of light in medium 2 divided by speed of light in medium 1. Yes, when we talk of the refractive index of the medium 2 with respect to 1, we will show it by the ratio of speed of light in medium 1 by speed of light in medium 2. If we write the refractive index of the medium 1 with respect to 2, then it is speed of light in medium 2 divided by speed of light in medium 1. And whenever we say that refractive index of any medium with respect to air or vacuum, we call it as absolute refractive index. Yes, what is absolute refractive index? When the refractive index is with respect to air or vacuum, that is called as absolute refractive index. And it is simply called as refractive index. If I say the refractive index of diamond, that is absolute refractive index of diamond is 2.42, then it means that the ratio of speed of light in air to the speed of light in diamond is 2.42. This is called as absolute refractive index. Yes. So, what is the refraction then? It is a bending of light when light travels from one medium to another medium. Why does the light bends? It is due to the change in speed of light from one medium to another medium, because light have different speeds in different media. Yes. So this ability of the medium to refract light is also expressed in terms of optical density. We can express to which extent the light is refracted by optical density. Then we will express using the terms like optical rarer medium, optical denser medium. What is optical rarer medium? It means the medium having lower refractive index. In this case, the speed of light is larger in case of optical rarer medium. And in case of optical denser medium, it is the medium having larger refractive index. Means here the speed of light is smaller. Speed of light is lower in a optical denser medium, and it is not related to mass density. This optical density is nowhere related to mass density. It is only related to the extent of refracting capability, the ability of that medium to refract light. It is expressed by using optical density. Yes, in optical rarer medium, what happens? The speed of light is more when compared to that of denser medium. Whereas in case of the optical denser medium, the speed of light is lower. So assume whenever the light is traveling from optical rarer medium to denser medium. This is rarer medium and this is denser medium. This is the normal. Now a ray of light is incident on the interface between the two media. When the light is traveling from rarer medium to denser medium, it will bend towards the normal. The light ray is refracted towards the normal because in rarer medium the speed of light is more. As it travels into denser medium, the speed will decreases, because of which this ray is bent towards the normal. What happens in case of light traveling from denser medium to rarer medium? Now this is denser medium and it is rarer medium. Light is traveling from denser to rarer medium. The light ray will bend away from the normal. It will bend away from the normal. If there was no media here, means if it has same media here, light would have traveled straight. But due to change in media, it has bent. How does it bend here? It has bent away from the normal because in case of denser medium, the speed of light is lower here. Once it enters into rarer medium, the speed will get increased, because of which it will be bent away from the normal. In this case, the optical rarer medium and optical denser medium will refract the light. In this way, we will express the refraction in case of optical rarer medium and optical denser medium.